Wait, let's look back at the conventional model again. We were all taught that current can be thought of as a flow of electrons. When a current flows, it creates a magnetic field around the wire. But does this theory stand up to scrutiny? When the switch closes, a voltage V appears across the wires, and the leading edge of the signal begins to propagate down the connection to the load, in this case a lamp. Observe the electrons jostling and moving around the circuit. This movement represents the so-called nudging effect that we have all been taught. The yellow arrows show the conventional loop and path of these charged particles. Remember that the binary step, represented by the red line, is propagating at the speed of light, c, for the medium. Finally, the complete loop is shown in yellow. Current I flows left to right on the upper conductor, whereas the electrons move in the opposite direction. This has been the theory taught to all students for well over 100 years.
The process described by the accepted theory is that electrons jostle each other, propagating the signal along the cable. The challenge with this model is that electrons have mass and cannot move at speed c for the medium, yet we are taught that the propagating TEM signal is caused by the moving electrons or charged particles. How can this be?
If this were an accurate or correct explanation of what happens, then what is the force pushing the charged particles back towards the energy source in the upper conductor? Does something flow across the leading edge of the pulse as it propagates towards the load at the speed of light for the medium? Also, if we look closely at the distances traveled, we can see that the transit distance for the complete loop is much greater than the distance that the leading edge has moved. This suggests that any transitory event that has occurred must have traveled faster than the speed of light. Here we see one copper atom with the outer conduction band electron moving from one atom to the next, creating this jostling effect. Also, this jostling effect, people talk about billiard balls in a tube, where the first billiard ball hits the second billiard ball, hits the third billiard ball, and so forth. However, remember electrons have mass, and if they did propagate across the front face of the signal, their perceived mass would be infinite. This is not possible, and we can verify this easily by understanding the Lorentz transform. So what does really happen? When the switch closes, the stored energy in the battery suddenly sees a non-open circuit. Hence, the TEM wavefront begins to propagate down between the wires. These wires are a transmission line with a characteristic impedance Z0 ohms and a velocity Vc. Both are dependent upon epsilon, the permittivity, and mu, the permeability. Because the wires guiding the binary step signal are not perfect obstructors, some of the energy ekes into the wire and energizes the atoms of copper. The loosely bound outer electron breaks away from the atom and is attracted towards the moving signal in the lower conductor wire and back away from the forward direction of the signal. As these electrons bounce from atom to atom, they propagate forwards in the bottom and backwards in the top. This minute movement in no way causes the E or H field to exist.